So how you been, guys? Okay, haven't seen you for a long time. So, who's that? um, so it's already 10 o'clock. Record to the cloud. Okay, right. So let's begin while the technician comes. So I asked you guys to watch the 4 videos. I hope all of you have. Had you all watched it or not? You have, okay. So basically I will go through quickly the stuff. I mean, in every review session I will go through the stuff I did in the videos quickly. And if you have any questions, hello sir. I think I don't need this now for today, but what I like you to do is just tell me which one of these is podcasted. Is this podcasted being right now?
No, because it's not on the screen.
So how do I make it? Yeah, just leave it there, and can you show me how to podcast it? But I want to be able to see the Zoom also at the same time, right?
So only one feed is podcasted?
Yeah, I know.
Yeah, so
yeah, but on the monitor I want to be able to see.
Yeah, that's fine.
Yeah, but at the moment I can't. So.
Right, so the right hand screen is podcast and then that's the Zoom. Okay, so that's on there and then the Zoom's on here.
Okay. Alright, okay.
So you don't need this, no?
No. Sorry.
It's okay.
Sorry to have bothered you.
No, it's okay. I'm sorry.
Yeah, I just wanted to check how to do this.
Yeah, we've been really busy. We've been going around everywhere.
Okay, thank you sir. Yeah, right. Okay guys, here we are. So sorted now, hopefully. Right, so basically what I'm going to do during the review session is to go through this 4 videos I asked you to do. I asked you to watch, and if you have questions, then you can raise during the review session, right? So let me go through them quickly. So this is the first video This is the first video I asked you guys to watch. So it's basically giving the contact details, right? Are you guys okay with this? Yeah, these are my contact details, and I need to watch it both the same. And this is the credit rating for the course. This is the aim and description for the course. I mean, if you have questions, please feel free to interrupt me. And
Sir, can you hear me?
Hello?
Can you hear me?
Yeah, I can hear you, yeah.
I can't see the screen.
You can't see the screen? Oh, sorry.
Nothing projected to us.
Okay. I think it's my fault, Asad. Just a minute.
Okay. Yeah, I can see it now. Thank you.
Okay. All right. Let me repeat it again. Yeah, it's my fault, man. Sorry for that. I apologize. So this is my contact details. Yeah, and this is the credit rating for the course. The prerequisite is statistical methods, but if you haven't taken it, it's okay. Right, go through the material that I gave you a website that contains the material for this course. So please go through that in your own time. And if you have questions, feel free to ask me, okay? And these are aims and description. You're right, man. This intended learning outcomes. These are the course contents for this course, right? And these are 4 recommended textbooks, but as I said before, you don't need any textbooks for this course. And the PDF copies of these 4, or not 4 actually, 5 books are on the course website, right? So if you go to the course website, which I showed you before, you can see the PDF copies. And if you want me to upload any other copies of any book, any other books, please let me know. I will do that, right? So you just email me any other book that you want me to upload. I will do it, okay? These are the teaching and learning process for this course. I'm sure you know that. And the assessment, well, the assessment is, there are 3 types of assessment. The first are the quizzes. So there will be 10 quizzes for this course. The first one is on the 13th of October, Wednesday, 11 a.m. So please go to this link. Go to this link and do the quiz and submit the answer using Blackboard. If you have problems accessing Blackboard, you can email the answer to me or give it to me in person whenever you see me, right? Okay, right. And that's the first assessment. The second assessment is the in-class test. It will be held on the 17th of December. Hello? You have a question? Yeah, it will be held on the 17th of December, and the formulas you need to remember are this in this link for the test. And I haven't decided whether it's going to be online or on campus. I think it's likely to be a mixture of the two. For those of you who are on campus, it will be on campus. For those of you who are remote, it will be online, I guess. And the final exam will be next year in January. So the formulas you need to know are in this link, and it will account for 80% of your mark. And as I said before, the final exam will be on campus. So if you're studying remotely, can you now screen? Yeah. If you're studying remotely, then you should come back to Manchester and do the final exam, right? All right, so that's the first video I asked you guys to watch. Now the second video is about motivation, right? It's about what is the motivation for you taking this course. So basically, extreme values and financial risk, it has 2 phrases: extreme values, financial risk, right? So extreme values, there are extreme values in everything, in flood, in hurricanes, in stock market, right? Whereas financial risk can be caused by extreme values. So whenever you see there's a big stock market crash, there's big extreme values that can cause financial risk, right? All right, so some parts of this course will be about extreme values, and the remaining parts of this course will be about financial risk, right? And of course, the 2 parts are related to each other, all right? And the motivation for you taking this course is to try to minimize the chance of financial disasters from happening, and try to and that's number one. Number two is to there are many people who are making huge amounts of money out of stock markets, and what you learn in this course and other courses like machine learning. I hope some of you are taking machine learning. Are you? No? There's a course called machine learning which is being taught right now by another professor, another lecturer. So you can use some of what you learn in these two courses to detect fraudulent activities, right, and catch people who make billions of dollars out of stock market. Okay. All right. Now, financial disaster. I think that I showed you this. You must have seen these pictures. So these are some. This is known as the Black Monday crash, right? There's a huge amount of money lost. This is known as the Japan stock price index crash, right? Lost a lot of money. And this is known as the dot bubble crash in 1999, and this is known as the Asian financial crisis in '97, right? And this is known as a Black Wednesday crash, '92, right? So these are some of the financial crises. I mean, they continue to occur every few years, and these crashes, as you know, are caused by, they are man-made crashes. They are not natural. Like they're not like for example a flood or hurricane or heat wave or anything like that. These crashes are man-made, right? So there are ways that these crashes can be avoided or can be minimized, right? So and some of what you learn in these courses and other courses tell you ways to do that, right? Okay, so that's one motivation for you taking this course. The other motivation is to, you know, as I said, there are many people making billions of dollars out of financial markets, and I'll show you some people here. This is Bernard. This guy like earned more than $62 billion, right? And this is another guy. This is one of the guys who founded the famous company JP Morgan, right? But still stole a lot of money, right? And so on. So there are many people like, I'm not going to go through all of it. I'm sure you guys watched the video, right? Excuse me. I'm sure you guys watched the video. If you haven't watched the video, please watch the video one more time. All right. So the next video I'm going to go through is what is an extreme value. I mean, how do you define an extreme value? There are many ways there are many ways that an extreme value can be defined, and in this course I will talk about three different definitions of extreme values, right? Okay, the first definition of extreme value is this one. So if you look at this picture, can you see it? Yeah. So you have like 365 days in a year, and you have like one data point for every single day, right? So the extreme value in this case is the largest point in the largest value in the year, right? So this is an extreme value. So this is the definition. This is what I call definition definition 1, right? So according to definition 1, the extreme value is the largest data point. Okay, all right. Now you may ask me why pick the largest data point. I mean, you can also pick the smallest data point. This is equal. The smallest data point is also an extreme value, but in this course, I will only talk about the maximum, not the minimum, because the theory that you will learn in this course applies equally to minimum, right? So whatever I talk about maximum also applies to minimum, right? Okay, so therefore I'm not gonna repeat. I'm not gonna repeat the theory for minimum. I'm gonna talk about only about the maximums of data, or maximum of processes. Okay. All right, guys. So that's the definition 1. Now definition 2. Definition 2 is this one. So in this definition, is different. Here you have the same process as in the first definition, right? You have the same process as in the first definition, but the difference is that what you do here is you draw a line which is in green, right? And anything that goes above this line is considered an extreme value, right? So this line here is known as the threshold, right? And normally I will use the notation U to denote the threshold, right? So anything that is above, anything that goes above this line is an extreme value. So for example, like in Manchester, for example, if you say it's very unusual in Manchester to have a temperature that is greater than 30 degrees centigrade, right? I mean, in the UK in general, it's very unusual to have 30 degrees above in temperature, right? So if you define the threshold to be 30 degrees centigrade, right, you can say that any temperature value that exceeds 30 degrees centigrade is an extreme value. You see what I'm saying? Yeah? Okay? Yes?
How do we decide the threshold?
How do you?
Decide the threshold.
Well, there are methods for deciding threshold. I'll talk about later. Yeah. Yeah. Okay, so in this case, the extreme value are data exceeding data exceeding the threshold, right? Is that okay, guys? So this is definition 2. Now the third definition, this is definition 3. So you have the same data, the same diagram as before. Now the difference between definition 1 and definition 3 is that instead of picking up the largest data point, here you pick the first few largest, right? So in this case, you not just pick the largest, you pick also the second largest, the third largest, the fourth largest, and the fifth largest, right? Okay, so this is known as definition 3, where the extreme values are extreme values are the R largest data values. So in this diagram here, R is equal to 5. Okay, yeah. All right, guys. So these are the three definitions I shall talk about in this course. But of course, I mean, these are not the only three definitions of extreme values. I mean, there are other ways. There are other ways that extreme values can be defined. But these are the three most common definitions of extreme values, right? Okay. Right. So the next video I ask you guys to watch is the number 4, video number 4, which is about distribution of extreme values under definition 1, right? I hope you guys watch this. And right now in this video, you have what we consider is, all right, suppose you have this data. Hello. Suppose you have the data x1 to xn, right, which are independently and identically distributed with CDF equal to capital F, right? Okay. So according to definition 1, I mean, if you don't understand anything, just please feel free to interrupt me and ask any questions you like. Okay. So according to definition 1, the extreme value is this guy here. The large. You may recall. You should go back to this picture here. This is the picture I showed you in definition 1. In this case, the extreme value is the largest data point, right? So if x1 to xn denote the data values, right, then the extreme value must be the largest data point, which is the maximum of x1 to xn. And I'm denoting it by m, capital M, subscript n. So this is the notation I shall use. This is the notation I shall use to denote an extreme value, right? Now, for statistical purposes, we need to work out the distribution of Mn. So that's what I'm doing here. So the CDF of Mn, which is given by this, is equal to this, and this is equal to this. Do you follow this? Because if the maximum is less than or equal to x, then every one of the variables has to be less than or equal to x, right? Okay, and because we are assuming independence, you can write this probability as this, right? Okay, and because we are assuming that each of these random variables has CDF equal to f, right? This guy must be f and this guy must be f, right? And this is a product of n terms, right? So this is equal to the nth power of f of x, right? So we have shown that the CDF of the extreme value is equal to the nth power of f of x. Is that clear or not? Any questions here, guys? Are you all okay? Okay. Okay. All right. So Now, what happens is that in real life, people are interested in extreme values over a long period of time, right? So, for example, what happens to the stock market, say, over 1 year or 2 years or 5 years, right? So in that case, your n, remember n is the number of data points. So if you're recording one data point every day, then you have, in 1 year, you have 365 data points, right? And in 2 years, you'll have 2 times that amount. In 5 years, you have 5 times that amount. So n is a pretty large number, right? So people like to know what happens to the distribution of the extreme value as n approaches a very large number, right? So in other words, in mathematics, we call it infinity, right? So we like to know we like to know what happens to this as n approaches infinity, right? So if you go to this slide here, you take the limit. You should take the limit of this as n approaches infinity. It's the limit of this as n approaches infinity, right? And this is where your math comes in, guys. I'm sure you're done, right? Because remember, CDF is a number between 0 and 1, right? Now, if you take if it takes a value between 0 and 1, but not including 1, then the limit of that will be 0, right? Whereas if f of x equal to 1, then the limit will be 1. So the limit will be either 0 or 1, depending on whether f of x is less than 1 or equal to 1, right? I mean, this is math that you should know, guys. I'm sure you know. You've done this math in your first year or whatever. Yeah. Okay. Anyway, so this limiting result is not very useful in practice because, I mean, what we have is that the limiting distribution takes either 0 or 1, depending on f of x, which is not a terribly useful result. I mean, it's not a result that you can use in practice, right? So the next question is, how do we make this into something that is useful? Now, this is where we go back to what you learned in second year. I don't know when you learned this, guys, but I think you guys took my course, right, in the first year, right? Some of you, Intro to Statistics. I think we talked about part of this in that course. Now, suppose you have a data x1 to xn, right? With population mean equal to mu, and the population variance equal to sigma squared. And let x bar denote the sample mean, right? Then I'm sure do you know this result here, which says that the limit of sample mean as the sample size approaches infinity is equal to the population mean, which is actually known as the strong law of large numbers, or SLLN for short. Now, this is not a very useful result because it says that the limit distribution, or the limit of a random quantity, which in this case is sample mean, is equal to mu, which is a fixed number. Mu is the population mean, which is a fixed number. So you cannot really use that result in practice, right? So it's not the strong law of large numbers is not a very practical result. It's not a practical result. So now, in order to convert that into a practical result, what we need to do is this. Instead of considering x bar, instead of considering the limit of x bar, you consider the limit of this, which is a scaled version of x bar. So instead of x bar, we consider x bar minus mu divided by sigma by root of n, right? And if you take the limit of this, then what you get, I'm sure you know this from your second or first year courses, that the limit of this as n approaches infinity is the standard normal distribution. And this result is the famous central limit theorem, right, or CLT. I mean, the central limit theorem is a very practical result, right? It is used in every textbook in statistics talks about central limit theorem. I mean, there's not a single statistical package, I mean, software package that does not use the central limit theorem. So it's a very practical result. So you see, from something which is not practical, from something that is not practical at all, we got something which is very practical. And how we did it is to look at, instead of looking at x bar, we have looked at a scaled version of x bar. So we subtracted mu, right, and divided by sigma by root of n. By the way, sigma by root of n is known as the standard error. Right, this guy here is known as the standard error, right? All right, now the reason I've shown you this is because going back to the previous slide, this is not a very useful result, right? Now I'm going to convert this into something that is useful, and the way I'm going to do it is the same as what we did here, right? So instead of looking at the limiting distribution of Mn, right, I'm going to look at the limiting distribution of the probability that Mn minus a scale factor and divide by another scale factor. So I'm going to look at Mn minus a constant Bn and divide by another constant An, right? And then I'm going to look at what happens to this probability as n goes to infinity. So you see, you see what I'm saying? So the idea here is that is same as what I showed you in the previous slide. Because the strong law of large numbers is not a very useful result, we converted that into something which is useful by considering a scaled version of x bar. And that's exactly what I'm doing here. Instead of looking at the limiting probability of Mn, we are looking at the probability of a scaled version of Mn, right? So which is Mn minus Bn divided by An, right? Okay, so this guy, all right, now the rest is math. So this probability is the same as this probability, right? Okay, and this probability is the same as this probability. You guys okay? Any questions, let me know. Now, because this is a maximum, right? Because this is a maximum less than or equal to something, right? Implies that each variable, each random variable within the brackets has to be less than or equal to this, right? That's what I have written here, right? And in the next line, I'm using the fact that x1 to xn are independent random variables. Remember, we are assuming that x1 to xn are independent, right? So using that fact, you can write this probability as the product of these probabilities. Yeah? You good? Am I going too fast or what? Are you okay? If I'm going too fast, let me know. Slow down, I will. Okay? Right. Okay, in the next line, because we are assuming that x1 to xn have the CDF f, capital F, right? This guy here must be capital F at this, and this guy here must be capital F at this, right? So what you have here is the product of the same term n times, right? So this must be equal to this, right? You all got it or not? Yeah. Any questions on this so far? You guys okay? What did I do? All right. Are you guys okay with this? Yeah? Okay. Right. So the next question, all right, the question I'm going to talk. We still have time, but the question that I will address in the next week video is what is the limit distribution of star, which star is this one, as n approaches infinity. Right? That's the question I will talk about next Wednesday. Right? All right. But we still have time. What's the time now? 30. It's only 35 now. So we still have time. So I will. I will ask. I would like to ask you if you have like any questions that. Do you have questions you like to answer on the stuff that I talked about today, or anything related? Yeah, you all right? You sure? Yes.
I just want to ask about the scaling factors and sort of what they are, how that's.
Yeah, that's a good question. That's a good question, Nicholas. Yeah, the scaling factors, AN and BN. They are chosen in an appropriate way so that you get a limit. I will talk about how to choose them next week. I mean, I'm not going to go too fast. I mean, I will show you how to choose these scaling factors, AN and BN, right? So that the limit is what you want, right? But I don't want to go too fast right now. So I think some of you have already watched week 2. Had you? So some of you might have watched week 2 videos. If you watch the week 2 videos, it tells you how to choose AN and BN, the scaling factors. But if you haven't watched it, just wait till next week. I will show you how to choose AN and BN, right? Yeah, that's a good question, Nicholas. Yeah. Now, one other thing I wanted to talk about, just to remind you, the first quiz is due on, is it 13th? Let me check. What date is it? You guys remember? It's due on the 13th of October, which is not next Wednesday. I think it's the week after, right? So I think some of you already asked me. Some of you told me that mathematics with finance. Some of you told me that you have problems doing that, because I saw that some of you have already done it. What are these guys writing? I can't read.
Are you year 3 or year 4?
Huh?
Are you year 3 or year 4?
This is for both. Yeah, both for year 3 and year 4. I should write.
You should write under professor.
All right. Anyway, what was I talking about is some of you sent me an email saying that you have problems doing quiz number 1. Had you attempted? I can give you a hint if you want me to. Had you tried quiz 1 yet or not yet? It involves this function sec, You know what this function is, right? Or you don't know? This is trigonometric function sec. In order to do this question, try to use the fact that this is equal to, am I correct? Or am I,
So it's a 2 on top, right?
there's a 2 on top. Yeah, you're right, man. See, even I get it wrong. So yeah, in order to do this is hint. This is hint for quiz number 1. If you haven't tried it already, yeah, try to use this fact that the sec of x is equal to 2 divided by e of x exponential of x plus exponential of minus x, right? Okay. I'm recording all these videos, so you can watch. But that I forgot to tell you already. There are 2 videos out of every session. There will be a video from the podcast, right? Which goes to this screen here, right? And I will upload that to the course website after the class. And there's also a video from the Zoom, which is also being recorded right now. So you have 2 videos from every session, the Zoom video and the podcast video. So you'll be able to watch both of them right after the class. I will upload both videos to the course website. You know the course website, right? Yeah. Okay. All right. Any other questions? Any other questions about the course you want to know? Yes.
We can upload these whenever we want.
Yes, Veronica. Yeah, you are right. You should upload it before the deadline, before 11 a.m. on the 13th of October. Yeah, I'm not going to accept late submissions. I mean, if you had some people last year had problems accessing, especially those of you guys who are studying remotely in China. They had problems accessing Blackboard. In that case, you can just email it to me. Email the scanned version of your answer directly to me, and I will mark them. Yeah. Okay. And I will mark the quizzes on the same day. So you will get to know what your mark is on the same day as the deadline. So the first quiz number 1, you will get to know your marks on the 13th of October. Yeah. Okay. And all right. So and also yes, Nicholas. Yeah.
How many people are enrolled on this course?
Oh yeah, that's been a big issue because this course has been full all the time. At the moment there are about 80 students. At the moment there are about 70 close to 80, I think. But there are still people on the waiting list. And I asked the TLO, I know many of you have been emailing me, I've asked the Teaching and Learning Office to increase the capacity further so that more students can take it. But it's not up to me to decide. Like, I have no control over what TLO does. I mean, I have no authority to say that they must increase so it's up to them to decide whether they're going to increase the capacity or not, right? So hopefully they will increase it. In that case, more the people on the waiting list can enroll for this course. So yeah, I hope that happens. Yeah. I mean, I'm happy with any number. Last year I had about Last year there were 50 students or something. So this year is already like 80. So it's more. Yeah. Yeah. Are you guys taking some other fourth year course apart from this one? You must be taking, right? One more course. Yeah. Yeah. Yeah.
What fourth-year courses would you recommend?
No, well, there is a course called Statistical, taught by Professor Yuan. Yeah, Statistical Modeling in Finance. Yeah, another hint. Okay, just one more hint in order to do quiz 1 is if you have two functions, say g and h. Sorry, excuse me. G and you're taking the limit as x, say, goes to plus infinity. Yeah. Right, then this, you can write this as, I'm sure you learned this in your year 1, so it's nothing new to you. This you can write as follows. This is known as the
Sir, does that only work if you're taking the limit as x goes to infinity, or can you take it for other limits as well?
Yeah, you can take it for other limits also, as long as, if provided, you can, it doesn't need to be up to infinity, but it can be any, it can be to any other limit, man, as long as I mean, I'm sure you know the L'Hopital's rule, right? If the limit of the numerator and the denominator are plus or minus infinity, then you can say that the limit of g divided by h is the same as the limit of g prime divided by h prime, where g prime is the derivative of g, h prime is the derivative of h. And also the same thing applies if the limit is 0, right? You can also have 0 as the limit and the 0 as the limit. Both, if both the limits are 0, then you can still apply the L'Hopital's rule, right? Yeah. You know what I'm saying? Yeah, if the limit is 0, then you can still say that the limit of g divided by h is the same as the limit of g prime divided by h prime. Yeah. You guys okay? Any questions? Are you okay, ma'am? That's funny. Okay, guys. So it's I think it's 10. Long, yeah. Okay, so anyway, before you go, guys, there's a tutorial session on Friday It's in engineering building B025. So if you don't know where that is, please make sure you find out. And that session will also be recorded using Zoom and also recorded using podcast. So please make sure you attend the session either online or in person. And for the tutorial, please go through the tutorial sheet, which I have already shown you. I mean, if you check my emails, I hope you read my emails, right? If you read my emails, you will know the tutorial sheet for Friday, right? And try to do as many of the questions as you can before the tutorial. And I will try to go through the difficult questions during the tutorial. Okay? All right, guys. So take care and have a good day. I'll see you later. Yes. Thank you. How are you, man? Oh, yeah. I'll just talk to you about it. Yeah.
Hi, I'm Carrie, the speaker at the door, and Dr. Parker. I'm teaching the next one. I'm just sure not all of the lecturers are
Okay.
reading about the window time, so sorry for
Yeah.
hovering at the door.
It's
Thank
okay.
you
It's
for the
okay.
picture.
Okay. Yeah.
Take care, have a great day. Hey, how are you doing? Does this look small to you? This lecture theatre?
Yeah, it usually it's bigger.
Yeah, that's what I thought.
But to be honest, I haven't been to many because I've been told to lectures
Right,
for my PhD.
right. Thank you for being here.
Yeah, just let me know whenever.
Yeah, so basically I just need to, can I just go through this account? I don't want to log on again. Hey, how are you doing?
I'm good. Here to offer help.
Yeah, thank you. Wait, are you here to offer help too? Are you here to offer help as well?
No, I'm PA.
You're, oh, Anna. Sorry, I'm like, it masks Zoom, all looks different. Okay, Anna is the TA, me, Ellen, is helping us with dual learning. Yeah. So I'm just, yeah, I have this for my lecture. And it's really just getting the Zoom up and running. Thank you for being able to come, Ellen.